Alrighty, so I got around to checking out the daily for today, and it was part two of the previous one. I think it is the same one as far as I can tell, but with just harder constraints or parameters. Um, so I submitted my solution for the previous one, and it worked. Um, it worked completely. The runtime is adequately high, I think, or comparatively okay. So, I mean, I can, since I already posted the answer or the explanation for it last time, I'm not going to go try to do everything again, but I guess I'll do the summary again. But, so the summary again is basically one, sort the points in increasing order, increasing x order, and but also secondarily also decreasing y order. So that's this statement here, sorting it where the key is not just, if you don't use a special key, then it would sort it in increasing x, increasing y. Here's increasing x, decreasing y. And then basically this is kind of optional. Use a monotonic decreasing stack to determine for any index the earliest prior index where y is higher, where point at index the point y is higher. So if you have it sorted and increasing x for any point, let's say this point, what is the earliest prior point where it's to the top left of it, and that would be necessary in order for it to build the rectangle where this point is considered the bottom right, and this point would be considered top left of that rectangle, the prior point being the top left. If there is no prior y where there is no prior point where the y is higher, and that means all the prior points are kind of impossible to be used in a rectangle built in that fashion, right? So you can't use Bob and Alice as those two things. Bob being the bottom right corner and Alice being the top right. So I think I can maybe say i.e. For any index used as Bob's bottom right corner, the first prior index of a point that can be used as Alice's top left corner. Now this is optional because technically it's just a shorthand for the next thing, which is so that's the monotonic decreasing stack here as a dummy, so that the stack never empties completely. And for any index, it removes anything from the stack that would have a lower y value, and then it takes the top of the stack's y value as the prior, as the previously bigger index or previously bigger y, and then it pushes the current point y and index onto the stack. And then part 3 would be the actual main thing, which is for any point to be used as bobs for any index, actually. Iterate over the sorted list of points for any index to use at where point at that index is considered as Bob's bottom right corner point. Iterate in reverse over prior indices, and keep track of count of possible Alice points. Can start with the index found in part 2. So if you're at this point and you found that maybe if you're at this point and you found that maybe there's a point right here that can be used as Alice's point, such that because maybe there's all these other points between this point and this point that is just below, it can't be, if it was anywhere above the y coordinate of this point, then it could be used as Alice. So if you're at this point, then you iterate over prior points where the prior point from there has to have a height that is between the height of that and the height of Bob. Iterate in reverse order over prior indices. Any index that falls in between the in between Bob's y, any index, actually say any point whose y falls between Bob's y and the current high y works, and will update / lower the high y to that. So for instance, let's say you have say Bob is at 100, 200, and Alice is first identified first prior with higher y is maybe 90, 250. Then iterate backwards. It's basically x backwards from x equals 90 to x equals 0, looking for a y that is between 200 and 250. Right? If you imagine 100, 200 here, 90, 250 here, that forms a rectangle, and then something that is still bigger than 200 and less than 250 could be a new rectangle where it doesn't kind of include the previous point or any of the previous points. So let's say, for example, 88 to 40 would work and would lower the upper bound y to be 240. So so iterate backwards from x equals 88, looking for a y that is between 200 and 240. Let's go ahead and just okay. So that's this thing here. For every index, this is treating as Bob's index. You have the xy coordinate for Bob. The starting point would be the first earliest starting point for Alice would be anything where the index is prior to this and the y is higher. If there is none, then just skip this because it's not possible. The current y is going to be basically Alice's y is going to be this. This is Alice. And this is Bob's point. Guess I really didn't need to use the x, but and then iterate over the previous stuff. Iterate over the previous indices, starting at wherever Alice index is, and if the previous y value is between those constraints, Bob's current y and Alice's current y, then this could be a new point for Alice. Increment the answer. All right, and then here again, the time complexity is O of n squared. As for each, as it requires a nested for loop. Outside iterates over Bob's points, Bob indices. Inside loop iterates over possible Alice indices. The sorting requirement is O of n log n, which is faster than O of n squared, and thus O of n squared dominates and dominates the speed of this algorithm. Space complexity, this is going to be O of n to use a monotonic stack to determine the earlier the first Alice point for any index, any Bob index. If this wasn't used, it would be considered an O of 1 solution here. So technically this wasn't necessary, I don't think. Just a slight optimization, but without it, this is just all constant.